In this problem, I'm finding all the real zeros of the polynomial. Um, and also it's saying use the quadratic formula if necessary. So if I'm ending up with a second degree polynomial and if it cannot be factored, then I will be using quadratic formula. Okay, so first to begin with, let me start this problem with the Descartes' rule of signs. Descartes' rule of signs says that the number of positive real zeros is either equal to the number of variations in sign change of the function, or it is less than by an even whole number. So this even whole number is always going to be 2, so which means you're reducing it by 2. This is something that you are going to do if you get the initial value of the 0 as 2 or above. So let me draw a little table. So here I'm also putting complex in here, which is the next section 1. So just follow the same for both. Okay, the last column is the total number of zeros, and I know here since the degree is 3, the total zeros has to be 3. So the first column is going to be the positive real. The second column is going to be for the number of negative real. And the third column I'm going to keep it complex. Okay, so Descartes' rule says that the positive number of zeros could be equivalent to the variation in the sign change of this function. So when I see here there is only one sign change because the first one is positive, second term is positive, but the third term is negative, so there's one sign change here. So that's a prediction that there could be one real zero. So for this particular part, I cannot apply the second part of this first sentence where less than a number by an even whole number. I cannot apply to that because that's 1, and I cannot take 2 away from 1 and still stay in the positive range. So it's just 1. Okay, so if I have to bring it up to the next step down here, I will still bring down the 1. Okay, so I'm going to jump into the negative part. So for negative, first I need to find the value of the function when x is negative x. 3 negative x the whole cubed, 5 times negative x the whole squared, minus 2 times negative x minus 4. So this would be negative 3x cubed plus 5x squared plus 2x minus 4. So here I'm seeing that there is a sign change 1, and there's another sign change here 2. So the number of negative zeros is 2. So here complex has to be 0 because the total has to be 3. Now since the negative 0 you have 2, I must apply the second part to it, which is equal to less than a number by a whole number. Again, it's 2. So what it is telling me is take down 2 from what you have. So 2 minus 2 is 0. This 1 is going to come down, and this, since this became 0, the 2 that disappeared is going to appear on the complex side. The total has to be 3. When I go horizontally and add it, I have to have a maximum of 3. This is what Descartes' rule of signs is saying. So what this is helping me to do the problem is, I know for sure, but I don't know when I finish the problem whether I will be on the first category where 1 real positive, 2 real negative, and 0 complex, so I'll get a total 3, or I may end up with 1 real positive and 2 complex. So here it's asking only for the real zeros. So at least I'm going to have 1 real 0 for sure here. Okay. So for that, the next thing I need is the rational zeros. So rational zero theorem. Again, I need the polynomial. So let me write the polynomial on this side. P of x equals 3x cubed plus 5x squared minus 2x minus 4. That's a polynomial given to me. The rational zero theorem says that if that you can list every rational zero of this function in the form of p over q, where p is going to be the factors of the constant coefficient. So p is the factors of the constant coefficient. In this case, it's the factors of 4. Again, don't worry about this negative sign because I'm going to take positive negative. So this is just, I would say, the factors of 4 is what I'm looking for. So plus some minus 1 plus some minus 2 plus some minus 4. divided by the factors of the leading term. In this case, it is leading coefficient. In this case, it's 3, so it's plus or minus 1 plus or minus 3. So if I list it out, it's going to be plus or minus 1 over plus or minus 1, plus or minus 2 over plus or minus 2, plus or minus 4 over plus or minus 1, and then or plus or minus 1 over plus or minus 3, right? So I can write that as plus or minus 1/3. The next one is plus or minus 2/3 and plus or minus 4/3. Okay, so the rational zero theorem says that if there is a rational zero in this polynomial, then it's in this list. What I have listed, it could be a 1, -1 or a -1, 2 or a -2, 4 or a -3, 1/3 or a -1/3, 2/3 or a -2/3, 4/3 or a -4/3. Okay, so the next theorem, the bounds theorem, is going to help us break the boundary, like to say, okay, all my zeros are going to be if there is rational zero between this number to this number. Okay, so for that, what I'm going to do is take these zeros that I found from the rational zero theorem, and I'm going to put them in this number line. So I know the first number, smallest number, is 1/3. Then I would say this next smallest number is 2/3. The next smallest number is 1. Then I would say 4/3. Then I would say 2 and 4. Same thing on this side. I will have -1/3. Yes, 0 will be there. -1/3, -2/3, -1, -4/3, -2, and -4. So the bounds theorem is saying that if you pick a number from this listed numbers randomly, and if you do synthetic division to this polynomial given, and if you end up with no negative entry on the last line, then whatever that number you're dividing by is going to be the upper bound, which means you cannot have any number above that as a 0. So I'm going to randomly pick. I'm not going to pick a fraction. I will pick a whole number. So how about if I pick, I can pick 2. I can pick a fraction. There's nothing wrong. I can pick 4/3 too. There's nothing wrong in it. But just for convenience, let me pick 2 to make it easy. So if I go back to my polynomial, let me write it again here. So the polynomial I have is p of x equals 3x to the third plus 5x squared minus 2x minus 4. Okay, so if I take this and do synthetic division, 3, 5, -2, -4, divide by 2, bring down the 3, 3 times 2, 6, 6 plus 5, 11, 11 times 2, 22, 22 minus 2, 20, 20 times 2, positive 40, 40 minus 4, 36. So this is telling me that since I don't have any negative entry down here, like since all these numbers are positive, so since all these numbers are positive, it's telling me that 2 is the upper bound. And that's what the theorem says. What that means is this is the maximum that the zeros can be. I cannot have anything above that. So 4 has been excluded by that. Okay. The same thing for the negative zeros. So for the negative zeros, the condition is whatever that line has to have alternatively non-positive and non-negative numbers. So which means I have to have a plus and a minus, or if it starts with a negative, then the next will be plus and the following will be negative, positive, and so on. Okay, so again for this, I'm going to, for convenience sake, I'm going to again pick -2. Okay, I'm picking -2. So again, I'm just randomly picking this number. I don't know really. 3, 5, -2, -4. And I'm going to 3 times -2 is -6, -1, 2, 0, -0, and -4. Now 0 is neither negative nor positive. So I would say that here also I'm seeing an alternate sign change. Okay, so -2 is the lower bound. So what this tells me is this -2 is the lower bound. Okay, now so that automatically gives me that -4 cannot be in the list. Okay, this, some of you can, when you do a problem, you don't have to do the bounds all the time, but sometimes when you have big numbers in the listings, it is better to do the bounds so you can cut short the number. And if I want, I can go back and check 1 and -1, or even 4/3 and -4/3, or even like 4/3 and -1. It doesn't matter. It doesn't have to be symmetrical either. And I can narrow it still further. But I think I'm going to use the steps for following the rational zero theorem. Rational zeros. Okay. So first, these are the 3 steps they ask you to do to find the rational zeros. The first step is to list all the possible zeros. We already listed them there, right? We already listed them, and it's here. So the second step is, it's saying divide using synthetic division to evaluate a polynomial at each of this to find one of the rational zero. Now, if you remember back, the factor theorem says that if I call a number as a factor, then my remainder has to be 0. So already I did synthetic division for 2 numbers where I found the bounds. Those are the bounds, but those are not the zeros. So what I'm telling here is, it has to be, the only options here is 4/3, 1, 2/3, 1/3 on the positive side, -1/3, -2/3, -1, and -4/3 on the negative side. Now, if you look back at the Descartes' rule of signs, we know that definitely there is going to be one positive zero. So if there is a rational zero, then I'm going to have 1 from the positive side. So this is narrowing my numbers to 1/3, 2/3, 1, and 4/3. So that's what I'm going to start with. So from these 4 numbers, for one of this, if the remainder is 0, that is going to be the first zero that I'm finding by using this second step in this process. So this could be done in 2 different ways. One way is using synthetic division, so I can pick these numbers and do synthetic division. Or the other way is, that's what I like the most, just using the remainder theorem, finding the value of it. So again, I'm going to pick 1 first because that's a small number and easy to handle. 3 times 1 cubed plus 5 times 1 squared minus 2 times 1 minus 4. So if I don't get 0 in this, then that's okay. I will go to the next number. 3 plus 5 minus 2 minus 4. So this would be 8 minus 6, which is 2. So it's not a 0, so that's telling me this is taken away from the list. So the leftover is now 3 fractions. So again, let me pick P of 1/3. Now, this part of this work, you can use your calculator too, and I would recommend doing that because it'll be easier for you to deal with. So I'm going to go 3 parentheses, 1 divided by 3 cubed plus 5 parentheses, 1 divided by 3 squared minus 2 parentheses, 1 divided by 3 minus 4. Okay, the reason I'm doing this is if this doesn't work, then I can use my upper arrow and bring this whole expression back down and just change the 1/3 to 2/3. So let me hit enter. I got a -4. So that's telling me this cannot be a 0, 2. 1/3 cannot be in the 0, 2. So now I need to check for 2/3. So what I can do, rather than typing this whole thing, I can go up using my upper arrow, just select it down, bring it back, just change this to 2, change this to 2, and still I'm not getting it. So let me go back again. Now the last leftover is 4/3. Four-thirds. Four-thirds will work. Ooh, 4/3 didn't work either. So one of the thing it's clear for me is that the positive 0 is not going to be a rational 0. Okay, the positive 0 is not a rational 0. So it could be an irrational number that I may get only if I go through the quadratic process. Okay, so let me hold here for a second and stop this. And now I'm going to go to the negative side. Okay, for negative, I have the numbers listed as negative 4/3, negative 1, negative 2/3, negative 1/3. And I'm going to pick because the first option here has a possibility of having 2 negative zeros. So if I'm still in the second option, I'm not going to see any of this. But let me randomly check some of these numbers. So let me do P of negative 1. To begin with, 3 times negative 1 the whole cube plus 5 times negative 1 the whole square minus 2 times negative 1 plus minus 4. Okay, so I have negative 3 plus 5 plus 2 minus 4. Ooh, here it comes. 5 plus 2, 7. Negative 7, 0. So I know x equals negative 1 is a 0 of this polynomial. So the one answer I'm looking for is x equals negative 1. So now the next step would be to take this number, x equals negative 1, and bring this polynomial 3 the polynomial that was given to us, just 3x cubed plus 5x squared minus 2x minus 4, and do step 2, which is do synthetic division and divide it by negative 1, just to confirm that the remainder is going to be 0. So let me bring down the 3, negative 3, 2, negative 2, negative 4, positive 4, 0. So this brought my polynomial down to 3x squared plus 2x minus 4 equal to 0. Now I need to solve this to find the other two zeros. So again, this cannot be factored. 4 times 3, 12, negative 12 and positive 2. So I have to use my quadratic formula. Quadratic formula is negative b plus or minus square root of b squared minus 4ac over 2a. Again, this is for ax squared plus bx plus c. So a is in this case is 3, b would be 2, and c is negative 4. So x is equal to negative 2 plus or minus square root of 2 squared is 4 minus 4 times a is 3, c is negative 4 divided by 2 times 3. So here negative 2 plus or minus square root of 4 plus, right, which is 4 times 4 times 4 times 3. So 16 times 3, which would be 48. So that's a plus 48 divided by 6. So 48 plus 4 is going to be 52, square root of 52. Again, I cannot use decimals in this problem, so I have to go through this process. So negative 2 plus or minus, now square root of 52 can be broken into, I think 52 divided by 4, which is 13 times 4 over 6. So I would go negative 2 plus or minus 2 root 13 over 6. Factor out a 2. So it's a negative 1 plus or minus root 13 over 6. Put 16 here. Okay, so simplify this. negative 1 plus or minus root 13 over 3. So the two zeros are x equals negative 1 minus root 13 over 3 and x equals minus 1 plus root 13 over 3. And I think this is what they're looking for, these three answers. X equals negative 1, x equals negative root 13 over 3, and x equals negative 1 plus root 13 over 3. Just an FYI, this is a negative number. The second, this is a negative number. If you find the value, both negatives, this will be a positive number. So if you come back to the problem, the answers are, these are the three answers. The three zeros are, if you say the three zeros are, it says enter your answer as comma separated list, and enter all answers including repetitions. We didn't have any repetitions, but we had the three answers. I can say the answers are x equals negative, there's another color here. So x is equal to negative 1, x is equal to negative 1 minus root 13 over 3, and x is equal to negative 1 plus root 13 over 3. Yes, this is the work for this problem. I think you can stop and rewatch it if needed. Now, one of the disadvantages of using a calculator on this problem would be you will not get these two answers. And you are going to get decimal answers if you do the calculator. This will be a decimal number if you use your calculator. And WebAssign it's not going to take that answer. I think they want the exact values. So you will have to follow the process for at least this problem. Okay, this entire process. You can skip the upper bounds. You can skip the Descartes rule, but you definitely have to do the rational zero theorem. Like at least these three steps that's been listed needs to be followed. The upper bounds and the Descartes rule, I kind of put everything in one to show that it's all applicable when solving a problem, but you can just, if you don't want those two, can be skipped. But definitely rational zeros needs to be tested, synthetic division needs to be done. And mainly what we are doing this is to take the third degree polynomial and to make it into a second degree polynomial. And then you can do quadratic formula, completing the square. Or if factoring works, then yes, you can do factoring. But if factoring works, most of the time, you can get the answer from your calculator itself. It'll be visible, and you can see the zeros perfectly. Here also you will see the zeros, but you'll see decimal numbers there. Like for example, see this value is what? Let me put that in my calculator just to show it to you. So negative 1 minus root 13 divided by 3, right? So this is negative 1.535. So if I use my calculator, I will see negative 1.535 as a 0. But I won't be able to write it back as negative 1 minus root 13 over 3. If I am able to do that, that's what the answer that they want in WebAssign. I hope this helps.